to the Brighter Broker real estate application for Salesforce. If you remember last time, I created a fuzzy matching algorithm using the Get Levenstein built-in method on Salesforce. And I'll give you a quick recap. Basically, if you look at the bottom method here, we call the Get Levenstein method, and we pass in two strings. And what it does, it returns an integer, basically the number of operations required to make those two strings equal. Those operations being deletions or additions, adding different values. So if you have cats and then cat, it will be one operation. Basically, you would delete the S in the first string, and you would have a Levenstein value of 1. So the purpose of this is to perform fuzzy matching. And in real estate data, look at addresses, condo numbers, city, postal codes. Real estate data is always messy. So having the ability to perform fuzzy matching is a huge value. And I'm really going to drill down on this and use it in other parts of the application. But here, I only use it to match subdivision records, subdivision names. So we ran an API, and I will show you this as well. But we did run an API, bringing property data into Salesforce. And the subdivision name that came in through the API was always messy. Now we have a subdivision record in Salesforce on which we'd like to match it. So we had to make sure that we could match a messy subdivision name coming in from the API with a neat or less messy object name for subdivision built into Salesforce. And I will show you that. We'll walk through the whole process again. But I just wanted to walk through some of the updates that I've made. Now, another update that I made was, instead of, and we're going to move up here, but basically, if you look quickly, you can see that these are just debug logs, just so I can check the values and do some testing. But if you look up here, you can see that we call a different method that gets us a threshold value, because before I was just putting a value in there. I was saying, okay, I don't want there to be more than 5 operations to make these strings equal. And those, basically that was just an arbitrary number based on some testing. And it was very crude. And so I did this new method, which is calculate the threshold. And basically what I'm doing is I'm looking at the string length, the average string length, because the length of the strings is a factor in how many operations you should tolerate. If average length is 20, if the average length of the strings is 20, then you can probably tolerate 3 or 4 or 5 operations to make those strings equal, as opposed to an average string length of 5. You don't want to tolerate 4, because that would be 4 characters that could be changed. So basically, this is a very crude algorithm, but it works for now. So basically, I'm looking at the average string length. I'm also looking at whether one string contains the other, because in some cases I noticed that the subdivision name would be contained in the other, in the version that comes in from the API, and vice versa. But they would have extra extraneous characters in there, mixing it up a little bit. So I said that, well, if one string contains the other, let's make this threshold percent 90% of the average string length. And then otherwise, let's do 33%. And 33% was a good number based on this data set. Now it could be, you might have to tweak it based on the data set, but I also plan to, to incorporate a little machine learning on the back end that would look at the data constantly and tweak this threshold based on the data set. So that's in the works. Wish me luck there, but it seems to be the right way to go and a good challenge to pursue. So, but yeah, so this basically if you look at this, this basically, provides a somewhat dynamic threshold based on the strings themselves. So I will, let's go ahead and take a look at that. So I do have a record here that doesn't have any data. I mean, this is the way it was imported from the tax record, so it's pretty raw. So I'll go ahead and click refresh property data. And this is an asynchronous call that's going to hit an API and populate most of these fields. Let's go ahead and refresh. Okay, so we have, you see latitude and longitude have been populated, showing the property on the map. I did have another video showing how I built this in the Lightning Web component. Now, one thing we don't have is a subdivision, and that comes from a different API. So that comes from our sale and mortgage API, which is like a tax record. But these are these are two different APIs. One comes from a list, more like a front end listing, real estate listing, and the other one comes from a back end, more like a tax record through the public records. So I'm just going to put anything here because this will update the sale and mortgage name will get updated through a flow on the back end. And so I'll just go ahead and hit that. And that's also an API. It's an asynchronous call on creation. So we'll go over here, and it looks like this data, is it populated? Yeah, it looks like it's populated. So here we go. It says Bully Rock Final 69. So that's the number. That's the name that has been given. The subdivision name that came in through the API. That's not the name. The name is Bully Rock. It's the name of the community, which is in Havre Grace, Maryland. So let's go back over here, and we see that the subdivision has been populated as Bully Rock, even though the name here says Bully Rock Final 69. And let's take a quick peek at the dev console. And let's go ahead and change this out. All right, so we're going to let that run again, just so we can get the logs. All right, so you see here, take a quick peek at the debug logs, and here where I have the system.debug logs, you can see where the Levenstein value against the threshold that was calculated. So one other thing that I did was I realized that in some cases you could have more than one match, based on, subdivision names that were similar. So I took and put those results in a map, and I got the lowest threshold, the lowest Levenstein value against the threshold. So that was one other thing that I did to make sure that we got the correct, the best value. And this one threshold is 4, but it wasn't the actually threshold was for Levenstein 16, so you can see that wasn't a match. But we're looking for the lowest Levenstein values as it relates to the threshold. And most of these, and the algorithm is doing what it's supposed to do. It's giving a higher value for ones that don't match. So here we have a threshold of 13, Levenstein distance of 9. So the Levenstein distance is below the threshold. So that's why we got a match there. So it worked pretty well, and I'm pretty happy with how that turned out. Now, I do want to show you quickly the algorithm that I did in order to get the lowest value. So in let's see here. The process HOAs and subdivisions method class. Now this is called that because we're going to also process HOAs the same way, the same exact way as subdivisions, homeowners associations, HOA. So if you look here, we're going to take, we took a map of all the threshold values, and we're looping over it and getting the lowest value. And so ID for return is the lowest threshold of those that were under the threshold value. So if there were 4 subdivisions that met the threshold, we only want the lowest one, which is usually the best one and the correct match. So that worked out pretty well. And finally, the last thing we did was we updated that class. Now, if you remember, in my callout, I removed the API key for this, but if you remember in the callout, I had all of the data in here. This class was about 250 lines long, and I was doing all the work here. I was making the callout, and I was updating records. I was converting the map, converting the JSON to a map. I was doing all that in here, which is obviously the wrong way to do it. So I went ahead and broke that out into a separate class. So now we have a separate class that's doing all the updates. So this is the class that's handling all the updates. I still need to do the same thing for the sale and mortgage process, but this works for now. So let's go ahead and walk through on the UI. One more. Let's see if I can find one more. This one has some of the values, but it doesn't have all of them. So let's go ahead and create the sale and mortgage for this. Just put in a value, click save, and then wait for that to populate. Now, one other thing we don't have here, we don't have the zip code, which would get updated with the refresh. So we have everything we need here, and see the subdivision has been populated. This one says Heathlands Trail Beach Creek, but it's just Beach Creek is the name of the community. So that worked out just the way we wanted it. And yeah, so that's all for today. I am still working on some updates to this button here. I want to do some updates to this to make it operate a little cleaner for the end user, and then a bunch of other updates on the map, the routing. A lot of different things are being done. So I look forward to updating you on all that, and see you next time. And if I don't before tomorrow, then Happy New Year, and talk to you later. Bye.